like it.
Class, before we go to the question, let me tell you why we want to learn this. You see from here, for this arithmetic progression, from here, first row, second row, third row, and the fourth row is easy for you to count. Then, how about when you see there are so many here, how are you going to count if you don't know the formula? How so many? So during ancient time, there is a boy only 9 years old. The teacher hated him very much. Why the teacher hated him? Because he is clever and naughty. Every time he can answer the question set by the teacher. So one day the teacher thinks, how am I going to let this boy listen to me? How to make him feel that he don't know, so he will listen to me. So the teacher go into the class, then give a question. The teacher very proud of. Please sum up from 1 to 100. So the teacher think that, oh, now you don't know how to answer. Teacher asked the boy, why you didn't take out any piece of paper to calculate 1 plus 2 plus 3 until 100? And the boy said, I already know the answer. So the teacher had him for the reason, should have the reason, because he is so clever, brilliant. Then teacher asked him, how you calculate this? So he tell, in his mind. He already calculated it in his mind. You see, 1 plus 100, 101. 2 plus 99, 101. 3 plus 98, 101. So all over here, 1 to 50. I have 50, 101. So 50 multiplied by 101, I get the answer 5050. Then this boy is only 9 years old and he can have this knowledge. And then sum up from 1 to 100 very quickly. So who is him? He is one of the great mathematicians. During 9 years old, he already have this mindset. Very brilliant. This is the one, Carl Friedrich Gauss. Gauss, one of the world's most famous mathematician. So he's already passed away, but the knowledge is still with us. Okay, so then we go to the question. I hope by giving you this story, you have some knowledge what is all about this arithmetic progression. Okay. Okay, before I go into geometry progression, I want to tell you a story. So for this one, why I show this picture means that this story related to the geometry progression. So once upon a time, there was a very rich man like to bully people. And then one day, a clever man, very clever man, saw this rich man, and then he feel that, oh, this rich man, I must teach him a lesson. So he went like this, then go to the rich man's house and say, can you let me live at your house. I do the work for you. Then no need to give me anything. You just give me food to eat every day, and then you just give me 1 cent as my salary, and then every year increase, multiple, one time, okay, every year times 2, and then the rich man say, 1 cent, okay, okay, no problem. The rich man think that, wow, this guy working for me for 1 year, and then I just give you 1 cent, and then every day I give you some food to eat. That's all. Very worth. So the first year, this rich man feel that, wow, too worth to have this guy working for me. Then the first year, 1 cent. The second year times 2, only 2 cents. And the third year, only 4 cents. Fifth year, the fourth year, 8 cents, and so on, right? This one to 16 cents. You see, working for 5 years and then not earning even 1 ringgit. You see. So the rich man think that, oh, too worth to have this servant for me. Then you see, keep on increasing. Just 1 cent, 2 cents, 4 cents, 8 cents, 16 cents, 32 and 64 cents. For the first few years, we don't think like anything, right? This one, even after 10 years, this one, after 10 years, not even have 10 ringgit. So it is too worth to have him as his worker. You see, after 10 years now, only 5 ringgit and 12 cents. Then after that, keep on double up, increasing T11. T11, then T12, you see, double up. Keep on, double up. 14 years later, 15 years later, 15 years later, and then 16 years later, 17 years later. How much? You see, you have the 600. And then 18 years later, whoa, first time more than 1,000, 1,300. This one stand, right? And then increasing to 2,000. 20 years later, you will have 5,000 for the salary. This is for the 20 years later. So for this one, the rich man still can pay, right? No problem. Then after that, you see, wow, this one, 1 year have to give 10,000. 10,000 already. The next year, wow, 20,000. The following year, 40,000. 24th year, wow, 83,000. Keep on increasing, and now the rich man feel that it seems that I have been cheated. You see, after 25 years, the rich man need to pay this clever man 167,000, and then the next year, you see, wow, 335,000. Then you see, keep on increasing. And then at the year of 28 years later, right? Already more than 1 million. So from here, you see the power of the geometric progression. Double up from 1 cent. From 1 cent after 28 years later, it will become 1 million. Okay, let us look at this question. The sum of the first n term of a progression is given by Sn equals to 3n squared minus 28n. Find the common difference. So for this question, the student tend to make the mistake. They think that they just need to find the x substitute inside this x1. Then they can find the common difference. But common difference for this one, there is t2 minus t1, because this one is the common difference. When you see common difference, this is AP. For AP, so we need to find D. D is equal to T2 minus T1. Then here given is Xn, but you need to find Tn, T2 minus T1. So X1, X1 is actually equal to T1. So if I substitute 1 inside, 1 squared minus 28, I will get negative 25. So for X2 equal to T2, this is the common mistake student make. Actually, X2 is not equal to T2. X2 not equal to T2. If you want to find T2, T2 is actually equal to X2 minus X1. To find the X2, you have to substitute the 2 inside the formula. Minus X1. So for this one, 2 squared minus 28 times 2, this one you get negative 44 plus 25. You get negative 19. That is for T2. After you find T2 and T1, you substitute into here. Negative 19 minus 25. So you will get 6. Okay, that is for the common difference. Then for B, for this one, we want to find the 6th term, T6. T6 equal by using the formula A plus M minus 1D by D. So the A will be T1, that is negative 25, plus 5, since we know the D is 6. Negative 25 plus 30, we get 5. This is one the way, or you want to use T6 equal to X6 minus X5, also okay. You will get the same answer too. You can try. You will get 5. So it depends on you whether you want to use this or this. For the formula, you can apply the formula, then get the answer. Okay, for this question, an arithmetic progression has 12 terms. The sum of all the odd terms is 54 and the sum of all the even terms is 90. Find the first term and the common difference of the progression. This one, we have 12 terms. How to do? We want to find the A and D. So for this one, for the odd term, write down like this: T1 plus T3 plus T5 plus T7 plus T9 plus T11 equal to 54. For this one, I can write down A plus 2D plus A plus 4D plus A plus 6D plus A plus 8D plus A plus 10D equal to 54. So for this one, 1, 2, 3, 4, 5, 6, 6A. Plus this one, 6, 12, 20, 30D equal to 54. So I have my first equation. Then for this one, for all the even term, T2 plus T4 plus T6 plus T8 plus T10 plus T12 equal to 90. So this one, A plus D plus A plus 3D plus A plus 5D plus A plus 7D plus A plus 9D plus A plus 11D equal to 90. This one I can get also the same 1, 2, 3, 4, 5, 6, 6A plus the D. For the D here, I add up all of this. I will get 36D equal to 90. This one is second equation. So now I have two equations. Since here I have 6A, so I use the second one minus the first equation. So I get 6D equal to 36. So my D is equal to 6. Then let's substitute into either first equation or the second equation. I will get my A. A equal to 54 minus 30 D over 6. Then I will get my A is equal to negative 21. So I complete. I get my D and A. So A is first term. My first term is equal to negative 21, and my common difference equal to 6 part A. Then for B, the last term means that T12 equal to A plus 11D. Can do it like this: negative 21 plus 11, 6. Negative 21 plus 66, I will get 45. Or I can do it like this: for the x n equal to n over 2, A plus L. For this one, this formula, so it's x12. X12 means that sum of these two, 54 and 90, 144 equal to 12 over 2. For the A is negative 21 plus L. L is the last term. Then for this one, 144 divided by 6 equal to negative 21 plus L. So here is 24 equal to negative 21 plus L. My last term will be 45. This is two ways, alternative way to do. Okay. I hope you understand how to apply. When you are doing this, when you are blur, just apply into use the formula apply. Then you can get the answer. Okay, let us look at another question. This one. After n years, the value of a new motorcycle is given by the equation. Find the value of the motorcycle after 7 years. Then B, calculate the number of years it takes for the value of the motorcycle to be less than 1,000 for the first time. So, for this question, the mistake the student tend to make is that the student may think that it is T7 because over here after 7 years the student just substitute by T7 4 7 0 0 8 over 9 7 minus 1. So this one is wrong. This one is wrong. For this type of question, you see after 7 years, this one you have to find T8 after 7 years. That is T8. T8 is equal to 4700 8 over 9 8 minus 1. So for this one, you will get 2060.7732. This one from your calculator. But you have to take note, this cannot be your final answer. If you write down this one, also wrong, because this one is RM, Ringgit Malaysia, 2060.77. 2 decimal place only for Ringgit Malaysia. You cannot have 4 decimal place. This is the common mistake too. So this one is correct. So if you take note, after 7 years, you have to take T8. Then for the B, for this one, less than 1,000 for the first time. So 4700 8 over 9 n minus 1 less than 1,000. So this one, 9 n minus 1, 1,000 divided by 4,700. Okay. So for this one, you have to use log to multiply. Put log on both sides. Then this one n minus 1 log 10 8 over 9 less than log 10 0.21276. Okay. So now do a wrong one. Usually the student do it like this. This one is the wrong one. Student tend to just do it like this. Over log 10 8 over 9. Then you will get n minus 1 less than 13.13998 and less than 14.13 998. So for this one, n equal to 14. So all this part is wrong. Okay. Why wrong? I'll show you another one. This part. After here, if you separate it for the log, you separate it, you didn't combine log 10 8 over 9, this part, and then log 10 0.21276. You separate it, you press from calculator, you will get n minus 1. This is negative 0.05115, while the other part is negative 0.67211. You see, here you have the negative. That's why you have to change the direction. So n minus 1, then change direction. 0.67211 over 0.05115. So n minus 1 greater than 13.13998. Then n greater than 14.13998. So our answer is n equal to 15. After how many years? After 15 years. It takes 15 years for the motorcycle to be less than 1,000 ringgit Malaysia. So this is the part you have to take note. Okay, this part. This is the thing that make you lose your mark. Even though you know that log divide by log are easy, you can get a value, but you forget that here you have a negative, because negative you still get a positive value. But this one you have to change the direction, make that n is equal to 15. Okay, I hope you understand this one. Then we can go for next one. Let us try this question. Diagram show a ball is having the first bound at 80 cm from the ground. The height of the ball on each successive bound is 0.9 from its previous height. 0.9. Find the height in cm of the ball in the 6th bouncing. This one T6. So from here, this question, not given GP, or AP, right? What are we going to use? So for this one, when you see is like this 0.9 from its previous height. So this one usually use GP because it's in ratio. This one is using ratio, not common different. Common ratio means that at first A is 80, then the circle one A 0.9 because the height is T1, T2, then T3 A 0.9, 0.9 from its previous height. Keep on decreasing the height. So for question number A, this one T6 equal to AR 5, A minus 1. This one is 80 times 0.95. You press from calculator, you get 47.2392 cm. That is for A, okay. Then for B, the total distance traveled by the ball until it stopped. Total distance traveled by the ball until it stopped. So how many times it bounce until it stop. How many times? Because here, can I say that is T10, T20, T30? Which one it will stop? No, we don't know, because it keep on decreasing. Then for this one, we can use sum to infinity. Sum to infinity, because it keep on bouncing until it stop. You have to find the total distance traveled. Means that for the first bound, 80 up, 80 down, and then the second one 72 up, 72 down, and so on. The total distance traveled by the ball until it stops. So this one, using sum to infinity, the formula is A over 1 minus R. For the A, at first is 80. Then 1 minus R is 0.9. So for this one, 80 over 0.1, that is 800. So this one, 800 is just the height, but not the distance traveled with just the height, 80, then 72, then so on. So for each time, this height will happen twice, up and down, going up, going down. So for this 800, you need to multiply total distance traveled equal to 800 times 2. So the answer is 1,600 centimeter. So that's the total distance traveled. So for each question, not just have to apply formula and get the answer. You have to see the situation. For this one, you have to times 2. Then you get the total distance traveled. Sometimes, you may ask me, do I need to plus this one? Because the total distance traveled, for this one, for this case, we are just starting from 80. This one is the first bound, 80 cm. So here is the first. But sometimes the question, the T1, let's say the T1, you start from here. Let's say here is 800, 100. Then it bounce and going down, right? Then bounce and going down. So for this, let's say also the same 0.9 means that here will be 90. 0.9. Then here 81, and so on. So for this case, sum to infinity, sum to infinity will be, let's say you take this 90 as the first one. So it will be 90 over 1 minus 0.9. You get 900. 900 is just one time going up, then going down. You have to times 2. So 1008 plus the first one, because this one only one time, no 2 times. So plus 100. That is 1009. So I have to see the situation. This one, both all are twice, up, down, all are twice. Just have to see the situation. This one, the first one is only one time. The rest, 2 times, up, down, 2 times. So from here, we have to times 2 plus the first one, only one time, 100. So it's important, not just applying the formula, but have to see the situation, the real situation. So hope you get what I mean, and then my explanation can benefit you. Good luck to all of you. Thank you. Okay, given that x plus 2, x minus 2 over 3, 3x minus 2 over 9 are the 3 consecutive terms of a geometric progression. Find the value of x. For this kind of question, we don't have the first term, we don't have the common ratio, not given, only given you these 3 consecutive terms, and then these 3 consecutive terms don't have any value, only have unknown. How to find the value of the x? And then this one is GP. For GP, you have to think about common ratio. Common ratio is R. So for this one, you have to think that Tn over Tn minus 1. So in this case, we need to use T3 over T2 equal to T2 over T1. If this question is AP, if this is AP, you will be using D, T2 minus T1 equal to T3 minus T2. But this one is GP, so we use common ratio. Then we substitute the value T3, 3x minus 2 over 9 over T2 is x minus 2 over 3. Then this one T2x minus 2 over 3 over x plus 2. Okay, mostly the student will make the mistake after this because they don't know how to do. To continue, we need to do the cross multiplication. So it will be 3x minus 2 over 9 times x plus 2 equal to x minus 2 over 3 times x minus 2 over 3. So for this one, you will get 3x squared minus 2x plus 6x minus 4 over 9. This one you will get x squared minus 4 over 3x plus 4 over 9. So here you see the denominator is 9, means that all of these we can multiply with 9 to get rid of this 9, the denominator here. So we will get 3x squared minus 2x plus 6x minus 4 equal to 9x squared minus 12x plus 4, all multiply with 9. So the 9 no more. And then this one we will get 6x squared minus 16x plus 8 equal to 0. All move to one side. Then we can factorize, get x minus 2, 3x minus 2 equal to 0. For this one, we will get x equal to 2 or x equal to 2 over 3. For that, find the value of x. So you may think that we finished already. The value of x is 2 or x equal to 2/3, 2 over 3. But not yet finished. You have to try. when x equal to 2, you substitute into the term here. So the first term t1 will be 4, t2 will be 4 over 3, t3 will be 4 over 9. Okay, no problem. And then if you substitute x equal to 2 over 3, your t1 will be this one, 8 over 3. Your t2 will be 0. Your t3 will be 0. So this one, x equal to 2 over 3 is not the value of x for this geometric progression. So for A, the answer is x equal to 2. Ignore this one, 2 over 3, already ignore. Because from here, you can find that is, with this one, the R is 1 over 3. T2 over T1, T3 over T2, we get 1 over 3 for the R. Then for the B, find the first term if x plus 2 is the 12th term of the progression. T12 equal to x plus 2. T12 is 4. 2 plus 2, that is 4. So this one is geometric progression. We are using AR n minus 1, 11 equal to 4. So we want to find A 1 over 3, 11 equal to 4. Then the A is equal to 4 over 1 over 3, 11. We will get the value 708588. That is the answer for this question. I hope you get what I mean for this one. When the question asking like this, you have to think about the either common ratio or common difference. Common ratio is for GP. Common difference is for AP, arithmetic progression. So before you do a question, you have to think, this question is AP or GP. Go to find the keyword for the question, GP. Then all your formula must be using GP. Cannot have AP formula. Okay.
Let's try some question for this topic. You can scan the QR code or the link given. Do check the answer with your teacher.
Hello everyone. Today we are going to learn systems of equations in Chapter 3 Form 4 Additional Mathematics. The first part we are going to learn is the systems of linear equations in 3 variables. Let's look at the general form of the linear equations in 3 variables. There is ax plus by plus cz equals to d. And where a, b, and c are not equal to 0. From this general form of the equation, we can see that the power of variable is 1 and it involves 3 variables, that is x, y, and z. And actually it is a linear equation, right? Okay. Then we have 3 types of solutions of the systems of linear equation in 3 variables. The first, we'll get one solution, which is one set of answer. Means that we can get one value of x, one value of y, and also one value of z, which satisfy all the equations given. Second, infinite solution means unlimited answers. And the last one, no solution at all. How do we solve the system of linear equations in 3 variables? We have 2 methods used. One is elimination, another one is the substitution. Let's look at the first example. The question is, solve the following systems of linear equations. Here we have 3 equations given, and notice that these 3 equations have 3 variables, that is x, y, and also z. They are all linear equations, right? Okay, so these 3 equations, we call it the system of linear equation. Okay, first, how do we solve it? To solve the system of equation means we need to find out the value of x, y, and z. Okay, first of all, I label the equation as equation 1, equation 2, and also equation 3. Let's look at equation 1 and 2. We have variable x and x. We can eliminate the x to leave y and z. So I do 2 minus 1. I will get y plus z equals to 1. I label it as equation 4. Next, I can do something with equation 2. I multiply it with 2. So all the terms here, I multiply by 2. I will get 2x plus 6y plus xz equals to 20. And I label it as equation number 5. Then, look at equation number 3 and equation number 5. We have 2x, 2x, I can eliminate it. So I do 5 minus 3. And I get 5y plus 7z equals to 9. I label it as equation number 6. Look at equation number 6 and equation number 4. Both equations has the variables y and z. I want to eliminate one variable. Maybe I want to eliminate variable y. So for equation number 4, I multiply with 5. Then I get 5y plus 5z equals to 5. I label it as equation number 7. Then I can minus 6 and 7. After that, I can get the value of z, which is equals to 2. Now we get one value already. We need to find another 2 value, that is y and also x. Okay, how do we do? We can substitute z equals to 2 into equation 4. Because equation 4, we have variable y and z. We have already the value for z, then we can get the value of y. So y, we can get the answer or the value -1. After that, we can substitute y equals to -1 and also z equals to 2 into the equation 3, so that we can get the value of x. 2x plus -1 plus 2 equals to 11, 2x equals to 10, and then x equals to 5. Now we get all the value for x, y, and z already. And after all, we rewrite the answer in this way: x equals to 5, y equals to -1, and z equals to 2. This method, we call it elimination method. Okay, next example. Solve the following system of linear equation. Okay, you can see that we have three linear equations here with variable x, y, and z. I label it as equation 1, 2, and also 3. And I noticed that for equation number 2, there are only two variables, which is y and also z. So I do something for equation number 2. From number 2 here, I make y as the subject of the equation. So I move negative 2z to the other side. Then I get y equals to 30 plus 2z. I label it as equation number 4. Then I try to substitute 4 into equation 1. The 3x minus y, which is 30 plus 2z minus z equals to negative 120. Then I will get, after you expand it, okay, I can get this, and after that I get 3x minus 3z equals to negative 90. Then I simplify it, become x minus z equals to negative 30. Then I make x as the subject for the formula, for the equation. Sorry. Okay, x equals to z minus 30. I make it as equation number 5. For equation number 4, y as the subject, and equation number 5, x as a subject, then I can substitute 4 and 5 into equation number 3. So I get z minus 30 plus 2z plus z equals to 180. 4z equals to 180, then I get z equals to 45. After that, I can substitute z equals to 45 into equation number 4 so that I can get the value of y, which is 120. And also I can substitute z equals to 45 into equation number 5 so that I can get the value of x. Now we got already one set of answer here for x, y, and also z. After all, I rewrite the answer as x equals to 15, y equals to 120, and z equals to 45. This is what we call the substitution method. Okay, so notice that just now we have elimination method and also substitution method. The answer which we get has one solution. Okay, how about solving the system of linear equation in 3 variables when there is no solution or infinite solutions? We look at the example. First, solve the following system of linear equation. Again, we have 3 linear equations with 3 variables. There is x, y, and also z. I label it as 1, 2, and 3. For number 1, I make the x as the subject of the equation. There is x equals to 4 minus 2y minus z. I label it as number 4. Then I try to substitute number 4 into equation number 2. And I get 4 minus 2y minus z minus y plus z equals to 1. I get 3y equals to 3. And finally, I get the answer y equals to 1. Then I can also substitute 4 and also y equals to 1 as well into equation number 3. 2x. So x here I substitute with 4 minus 2 y, where y is 1, minus z plus 1 plus 2z equals to 2. Then in the bracket here, I will get 2 minus z. After that, I expand it, become 4 minus 2z plus 1 plus 2z equals to 2. Negative 2z plus 2, I get 0. And 4 and 1, I move to the other side. 2 minus 4 minus 1, I will get negative 3. So one side is 0, another side is negative 3. 0 is not negative 3. So this implies that this system of equation has no solution. Okay? Alright, we look at another question. Okay, this is the example. Still the same question. Solve the following system of equation. Okay, we can see that we have 3 linear equation with 3 variables x, y, z here. Okay, first of all, again, I label it as 1, 2, and also 3. Okay, so here I plus 1 and 3 because I want to eliminate z in these 2 equations, leaving x and y. Okay, then I get negative 15x minus 26y equals to 63. I label it first as equation number 4. Okay, then for equation number 1, I multiply it with 6 because I want to make the variable same as number 2, 6z and also 6z. Okay, so I will get 12x plus 30y minus 6z equals to negative 54. I label it as equation number 5. Then for equation 2 and 5, add it up. Okay, so I will get 15x plus 26y and no more z because 6z plus negative 6 is 0. Okay, equals to negative 63. This is equation number 6. After that, I do something here. There is 4 plus 6. 4 plus 6, negative 15x plus 15, I get 0. Negative 26 plus 26 at 26y, I get 0 also. And then 63 plus negative 63 also get 0. Means that 0 equals to 0. And when you see this implies that the system has infinite solution. So this is for the solution. 3 types of solution. First is one solution, second no solution, and then the other one is infinite solution. Next, we come to the next part, which is the solving problems of the linear equations in 3 variables. We look at this example 1. We read through the question first. A factory assembles 3 types of toys, Q, R, and S. The total time taken to assemble 1 unit of R and 1 unit of S exceeds the time taken to assemble 2 units of Q by 8 minutes. 1 unit of Q, 2 units of R, and 1 unit of S take 31 minutes to assemble. The time taken to assemble 2 units Q, 1 unit of R, and 3 units of S is 48 minutes. Question A. If x, y, and z represent the time in minutes taken to assemble each unit of toys of Q, R, and S respectively, write a system of equations to represent the above information. Okay, here in this example, I can see three important information. There is number one, the total time taken to assemble 1 unit of R and 1 unit of S, and this the time taken to assemble 2 units of Q by 8 minutes. Here we can write a linear equation, and another linear equation we can get from this information: 1 unit of Q, 2 units of R, and 1 unit of S take 31 minutes to assemble. Third information is the time taken to assemble 2 units Q, 1 unit of R, and 3 units of S is 48 minutes. This we can also write a linear equation. So we have 3 linear equations that we can write for this question. So first of all, we need to know that we represent Q, R, and S respectively with X, Y, and Z. So this is the first linear equation we get from information. The first information, Y plus Z minus 2x equals to 8. The second one is x plus 2y plus z equals to 31. The next one is 2x plus y plus 3z equals to 48. This is the system of equation that we can get from this example. Okay, question B. Hence, find the time taken to assemble each type of toy. Time taken. What is the time taken? Time taken is represented as x, y, and z. Means that we have to solve the system of equation in 3 variables that created in question A to get the value of x, y, and z. Okay, we look at the solution. First of all, again, we label the three equations in 3 variables as 1, 2, and 3. Here, I notice that in equation 1, equation 2, we have same z variable. For z, the coefficient is 1. Same. So I can do something for equation number 2 and 1 here. I minus 2 and I do 2 minus 1. Then I get 3x plus y equals to 23. I label it as equation number 4. After that, I'll multiply 3 with equation number 2 to get 3x plus 6y plus 3z equals to 93. After that, I do elimination. 5 minus 3, equation 5 minus equation 3 to eliminate the variable z here. Then I get x plus 5y equals to 45. Okay, notice that equation number 4 and also equation number 6 has only 2 variables. There is x and y, So I can do something to these 2 equations. First, I can multiply 3 with equation number 6 so that I can get 3x plus 15y equals to 135. I label it as equation number 7. Then 7 minus 4 to eliminate 3x, 3x. Then I get 14y equals to 112. I can get the value of y, which is equals to 8. Next, after I get the value of y, I substitute it into equation number 6. This is equation number 6, so that I can get the value of x. So x here, after I calculate, I get 5. Then I can also substitute x equals to 5 and y equals to 8 into equation number 1. This is equation number 1, so that I can get the value of z. X plus z minus 2 times 5 equals to 8, then z equals to 10. So this is the solution for this system of equation. 5 equals to 1, x equals to 5, y equals to 8, and z equals to 10. Next, we look at example 2. A fruit store sells 3 types of fruits: orange, apples, and pineapples. The monthly cost being 6,850 ringgit for 2,150 of fruits. The cost of an orange, an apple, and a pineapple are 2 ringgit, 3 ringgit, and 4 ringgit respectively. The sale price of an orange, an apple, and pineapple is 3 ringgit, 4 ringgit 50 cent, and 5 ringgit 50 cent respectively. If the fruit store wants to make a profit of 2,975 ringgit, find the minimum number of fruits which each type which has to sell. So this is the question in example 2. Okay, so the question is we need to find the number of fruit of each type. Means that we need to get the number of orange, the number of apples, and the number of pineapples. And these are the information given. 6,850 is the cost, and 2,150 means that this is the total number of the fruits. And we have the cost of an orange, apple, and also pineapple. And also we have the sale price. Okay, next we have the total profit. This is also a very important information. Okay, how are we going to write the system of equations? Okay, first of all, we let x to represent orange, y as apple, and also z as the pineapple. Okay, we have the information for 2,150 of the fruits, which is the total number of the fruit. So we write x plus y plus z equals to 2,150. This is equation number 1. The next equation is about the cost, the monthly cost, which is 6,850. And we multiply 2 with x, 3 with y, and 4 with z, because 2, 3, 4 is the cost of the fruits, orange, apple, and pineapple respectively. This is the cost, and I label it as equation number 2. Next, equation number 3, I want to write the equation for the information about the profit. The profit that he made is 2,975. So what is the profit for each type of fruit? The sale price given here, for example, for orange, it is 3 ringgit, and the cost is 2 ringgit. So what is the profit 3 minus 2 equals to 1, isn't it? Okay, and then for apple, the sale price is 4 ringgit 50 cents, the cost is 3 ringgit, so the profit made is 1 ringgit and 50 cents. And so as the pineapple, 5 ringgit 50 cents minus 4 ringgit make a profit of 1 ringgit and 50 cents for a apple. So this is how we write the equation: x plus 1.5y plus 1.5z equals to 2,975. I label it as number 3. Okay, now what can we do? We look at equation number 1. From equation 1, I make x as the subject of the equation, so I move x and y to the other side to get x equals to 2,150 minus y minus z. I label it as number 4. Then I substitute 4 into equation number 2. Then I get this equation. After that, I open the bracket. I get 4,300 minus 2y minus 2z plus 3y plus 4z equals to 6,850. Then I can get y plus 2z equals to 2,550. I label it as equation number 5. After that, I can also substitute number 4 into number 3. This is equation number 3. Okay, then I will get 0.5y plus 0.5z equals to 525. I simplify it, means that I divide by 0.5 for each term. Then I will get y plus z equals to 1,650. Then I make y as the subject of the equation. Y equals to 1,650 minus z. I label it as number 5. Since I want to I label it as number 6. Since I want to substitute number 6 into number 5. Okay, after I substitute, I get 1,650 minus z plus 2z equals to 2,550. Then I get the value of z is 900. Okay, then I substitute z equals to 900 into equation number 6 to get the value of y, which is 750. After I get the value of y and z, I can substitute both into equation number 4. This is equation number 4 to get the value of x. Then I minus, I get x equals to 500. Okay, since x represents the orange, so orange is 500. Y represents apple, so apple is 750. And z represents pineapple, so pineapple equals to 900. We rewrite the answer after we do all the calculation. Okay, so here actually we use the method of substitution. Now we come to the second part of this chapter. There is simultaneous equations involving one linear equation and one non-linear equations. Okay, these equations involve two variables, and we notice that these equations involve one linear equation, another one is non-linear equations. Okay, what are the examples for linear equation? I give you some example here. First one, 3x plus 2y equals to 8. A minus 5b equals to 9. 6m minus 7 equals to n. Here we can see that it is linear equations because the variable has power 1 only. Okay, means that x and y, the power of x and y is 1. Here a and b is the variable and their power is 1 also. M and n has the power of 1 also, and m and n is the variables. Okay, and then for the example for the nonlinear equation, first we have x plus 3 y squared equals to negative 1, xy equals to 8, 1 over x minus 1 over y equals to 2. The first example we can see that the power of y is 2, means that it is more than 1, so it is nonlinear equation. Okay, for the second one, the variable x multiplied by variable y multiply variable x multiplied by variable y. And the third one, it shows that x and y as the denominator. So these are the example for the nonlinear equations. Okay, how to solve? How do we solve the simultaneous equations involving one linear equation and one nonlinear equation? We have three methods here. First, elimination. Second, substitution. And the third one is graphical representation. Okay, first, we use elimination method to solve these simultaneous equations. Give your answers correct to 3 decimal places. Okay, these are the two equations. First, you look at equation number 1, 2x plus y equals to 4. This is the linear equation, right? Okay, second one, x squared minus 2xy equals to 3. We look at this form of equation. This is nonlinear equation. Okay, how to solve it? Okay, we can do elimination. Okay, next, look at this one. For equation number 1, I multiply it with 2x. Okay, then I get 4x squared plus 2xy minus equals to 8x. I label it as number 3. Why I do so? Because I want to eliminate 2xy and 2xy here. Okay, so I do 2 plus 3. Then I get 5x squared equals to 3 plus 8x. Okay, from here, actually we can see that it is a quadratic equation, isn't it? So we write it in the general form. Okay, we put all the terms to the other side, and the other side we make it 0. Okay, so we get 5x squared minus 8x minus 3 equals to 0. Okay, after this, actually you can use your calculator to get the answer for x. Okay, after we calculate, okay, using calculator, I get this answer. X equals to 1.914, and then another value of x is negative 0.314. Okay, so can you write in this way? Something like the factorization? No, because the value of x is decimal. We never write in this way. Okay, this is wrong. Okay, if you write this, the mark will be deducted. Okay, so what can we do if the value of x is decimal? We can use formula. Okay, we know already how to solve the quadratic equation. First, we can use factorization. Second, use the formula. Okay, then the third one is completing the square method. Okay, so in this case, the correct method is using the formula. Okay, so this is the formula that we use. We substitute all the value of a, b, c in this quadratic equation into the formula. Okay, so actually this method is very important so that we can get mark. Right? Okay, the answer, we put it in 3 decimal places because it is required in the questions. Okay, so for one of the value of x equals to, which is equals to 1.914, we can substitute it into equation number 1 so that we can get the value of y, right? Okay, value of y after we calculate is 0.172. Okay, when x equals to negative 0.314, then the y is 4.628. Okay, so here we can find that we have 2 sets of answer. Okay, we rewrite it. X equals to 1.914, y equals to 0.172. Another set of answer, x equals to negative 0.314, y equals to 4.628. Okay, so please take note that since the question needs 3 decimal places, so your answer should be in 3 decimal places. Next, how about the substitution method? Okay, this is the equation that we have. X plus y equals to 5. And then x squared plus y squared equals to 37. We label it as equation number 1, equation number 2. Okay, from number 1, I make y as the subject. Y equals to 5 minus x. And I substitute this into equation number 2. Okay, then I get x squared plus 5 minus x squared equals to 37. I expand it, I can get this. Okay, after that, I will see that it is a quadratic equation. Okay, so again, quadratic equation, if you want to solve it to get the value of x, okay, there are 3 ways. First, factorization, second, formula, and third, completing the square method. Okay, so look at this, 2x squared minus 10x minus 12 equals to 0. Okay, if we can simplify it, please simplify it first before you find the value of x. Okay, simplify it first. We get x squared minus 5x minus 6 equals to 0. Okay, then we see whether it can be factorized or not. Okay, if it can be factorized, we write this method. Okay, or after you come to this quadratic equation, you can use your calculator to get the answer for the value of x. Okay, so if the value of x here is the integer, then you can means that actually you can do the factorization. Alright, okay, maybe some of the students, after they do the factorization, they forgot to write equals to 0. This is wrong. Okay, so please take note. You have to write equals to 0 because the factor here, only then we can say factor x minus 6 equals to 0 and x equals to 6. X plus 1 equals to 0, then we can say x equals to negative 1. Okay, so we have 2 answers for x, and we substitute one by one into this y equals to 5 minus x to get the value of y. So when x equals to 6, y is equal to negative 1 after we calculate. When x equals to negative 1, y equals to 6. So we have 2 sets of answer here, x equals to 6 and y equals to negative 1. Another set of answer, x equals to negative 1, y equals to 6. Okay, the third method to solve the simultaneous equation is using graphical representation. Okay, I give you a simple example here. There is y equals to x minus 4. This is the linear equation. Another nonlinear equation is y equals to x squared minus 4x plus 2. Okay, so we have to use graph to find the value of x and y, okay, which is satisfy the two equations here. Okay, first of all, we need to construct a table. Okay, first we put x, and then after that we have to find the value of y in the first equation and also find the value of y in the second equation. Okay, let's say x, I use 0, 1, 2, 3, 4, and I substitute 1 by 1 into the equation. Let's say 0, when I substitute into this equation, y equals to 0 minus 4, I get negative 4. So, and so on, right? Then I can get this value of y. Okay, after that we plot the graph. Okay, we plot the graph for the linear equation first. Okay, I can get this, right? And I found that it is a straight line, right? And second one, this is a second equation. I also plot it, and I found that it is a curve. And I noticed that there is an intersection between the straight line and also the curve at 2 points. Okay, and I get the coordinate for the 2 points here. The first coordinate is 3, negative 1. The second one is 2, negative 2. So this is the solution of this simultaneous equation using graphical representation. So I can say that x here has two sets of answer. X equals to 3, y equals to negative 1. Another one is x equals to 2, y equals to negative 2. Okay. Okay, next, we also got solving problems involving the simultaneous equations. Okay, look at the example here. The diagram shows a rectangle ABCD. This is ABCD inside a circle with the points ABCD on the circumference. Okay, given that the perimeter of the rectangle is 238 centimeters, means that AB plus BC plus CD plus DA, the total length is 238 centimeters. Okay, this is the very important information, the first information in this question. Okay, the second information, what is that? The diameter. The diameter of the circle is 101 centimeter. Okay, what they want you to find the area of the shaded region. This is the area of the shaded region, and you can use the pi as 3.142. Okay, for this question we need to construct two equations, okay, so that we can get the solution. First, okay, we use the information for the perimeter of the rectangle for ABCD. Okay, first of all, we can let the length, okay, as y and the width as x. All right. So how to get the perimeter? There is 2x plus 2y equals to 238. Okay, this is the information that we get. Okay, after that, we find that it can be simplified. I divide it by 2. I get x plus y equals to 119. I label it as equation number 1. Okay, then the second information is about the diameter. Okay, so in this diagram, I draw a diagonal for the rectangle. I draw a line for BD. Okay, and actually this BD is the diameter of this circle. Okay, and then the O is the center. Alright, so how to get this BD? How to get this BD? You can see that actually it forms a right angle triangle BCD, isn't it? Okay, so we use Pythagoras Theorem, okay, to do to create the equation. That is x squared plus y squared equals to 101 squared. Alright, then x squared plus y squared equals to 10,201. This is for the equation for the information 2. Okay, so I label it as 2. And we can see that the first equation is the linear equation, the second equation is the nonlinear equation, right? Okay, so what can we do here? From equation number 1, I make the y as the subject for the equation. So I get y equals to 119 minus x, and then I label it as number 3, and this number 3 I substitute into equation number 2. Okay, so x squared plus y squared is 119 minus x squared equals to 10,201. Then I expand it. Okay, after that I can get a quadratic equation. Okay, let's try to simplify it. If it can be simplified, we have to simplify it. Okay, very important. So here I can divide it by 2. All the terms divide by 2. I get x squared minus 119x plus 1,980. Okay, equals to 0. Then if it can be factorized, we do the factorization, or we use the calculator to get the value of x. If it is integer, means that it can be factorized, right? Okay, so here it can be factorized. That is x minus 20, x minus 99 equals to 0. So one of the x, the value of x is 20, another one is 99. Okay, when x equals to 20, what is the value of y? 119 minus 20, we get 99. When x equals to 99, y equals to 20. Actually, they are the same, isn't it? The two sets of answer. But since we let y is the width, which is shorter than y, so we use this answer, x equals to 20 and y equals to 99. Okay, so we got this answer already, but the question asks us to find what? The area of the shaded region. So how to get this area of shaded region? Okay, actually very easy. We can see that this is a circle. The area of the circle minus the area of the rectangle. Okay, circle minus rectangle. Okay, what is the formula for the circle? Pi r squared, right? Okay, what is the area of the rectangle? The length multiplied by width, isn't it? Okay, so pi r squared, what is the r? The diameter is 101, so the r divided by 2, you get 50.5. And then pi, I use 3.142 to get the answer, and minus this area of rectangle, 20 multiplied by 99, we get this answer, 6,032.89 centimeter square. Okay, so this is the solving problem for the simultaneous equation. Right, we come to the end already. That's all for today's lesson. Okay, I hope you can learn how to solve the simultaneous equation and also the system of equation in 3 variables very well. Okay, finally, I wish you all the best. Let's try some questions for this topic by using the QR code or link shown in the screen. You can check your answer with your teachers.